Class, can you see my slides?
Yes.
It's on frame, right?
Yes, madam.
Okay, thank you.
Yes, madam.
Okay, so this is a very typical frame, okay? But unusual is because when there is in the different, the support is at different level, okay? But we are going to try on it, okay? So this is an indeterminate system. So maybe we can start with determining how many redundants in this structure. Okay, so what should we do? It will be just using the D equation similar to beam. Okay, so what we have R minus N and minus C. Okay, so how many support reaction in this case? Anyone can help?
Five.
Thank you. And N will be always 3. No C in this case. So we have 2 degree of it, indeterminacy, or we have 2 redundancy here. So if you see that the question here, I have summarized that. Okay, so they said support D, I suppose. Support D settles 100 EI. Okay, means that there has a displacement at D, okay, which is going down, okay, 100 EI. Okay, meter. Okay, so and then the first question is, please sketch 3 possible primary structure. Okay, so in the flexibility method, you always have 1 primary structure. Okay, but now it asks you to sketch 3 possible primary structure. Okay, so how you need to provide 3 cases where each cases you remove 2 redundants. We will have a look on that. Okay, then problem number 2 is determine the flexibility matrix. Okay, flexibility matrix, remember, it will be about this. Okay, but I believe that at this B, okay, it means you to solve for the redundance. Okay, so even though the flexibility matrix, you just need to write this. Okay, then the number C is ask you to sketch the shear force diagram and bending moment diagram. Looking at this, to be completed in 40 minutes. So means that you need to be very firm, okay, or you know the process very well. Means that once you get the question quickly without any thinking of, oh, what is the step, first step, second step, or third step, and so on. So you need to directly, okay, proceed with your analysis. Okay, so therefore, I hope that all will always participate in the tutorial session, okay, to gain your, familiarity with these methods. Okay, so let's have a look on how to solve the A. Okay, sketch 3 possible redundants. Okay, meaning that you can remove any of the 2 redundants. Okay, in this case. So if you can see that, this is our real structure. Okay, we have AY, we have AX, okay, we have MA, okay, we have DY, we have DX. Okay, if you are not familiar with how to change it to change the support condition, okay, I will advise you to directly put in terms of forces. Okay, meaning that you just put the direction of forces AX, AY, MA, DX, DY, okay, in your real case. Then you determine the redundance number, like for example, you have 2 redundants here, and then you are going to remove 2 of these external redundant or support reaction. Okay, just remove any 2. But remember, please make sure it is stable. Okay, so for example, the case 1. Okay, the possible number 1. Let's see what has been taken. If you can see that, dy and dx has been removed. Okay, 2 of these redundants. This become a cantilever frame. Okay, so this is possible number 1. you can analyze using this case. Okay, but you need to remember all the loading. If you do not put the loadings, you have this answer wrong. Okay, because we are sketching primary structure. Remove all the redundant, remain the real loads. Okay, so possible number 2, what has been removed? Okay, this has been removed, dx and ma, if you can see that. Okay, so again, if you are not familiar, just write. Okay, I have still ax and ay, but we don't have any ma. Okay, and we have dy here. So ma and dx is redundant. Okay, 1 and 2. Okay, so possible number 3. So this is also pin and roller. Okay, what is being removed here? It is MA and AX has been removed. Okay, as the redundant. So what you have right now is you have AY and you have DY and you have DX. Okay, so it will be up to you to choose which one is more suitable, convenient for your calculation. Okay, so but still read the instruction clearly. Okay, in case the redundancy has been given to you, so you need to follow exactly as instructed. Okay, so now let us start with solving B, which we need to solve for the redundant forces. So we need to create a primary structure. So in this real case, if you can see that we have D equal to 2. So meaning that we are going to have one primary structure. And we are going to have 2 redundant structure. I will put MI here. So means that I'm going to have M1, I'm going to have M2. Okay, so this M1 will be depends on my R. My R1 is what you choose for the first redundant, and M2 will be your second redundant. Okay, so now here, if you can see that we have taken dx and dy as our redundants. Okay, so in the primary structure, you need to remove all the dx and dy. So if you can see that dx, dy has been removed. Okay, and in the first redundant, so R1 is equal to dx. Okay, so you apply back the dx 1 unit force. Okay, the direction is up to your assumption. Okay, and then in your redundant structure number 2, you have d equal to dy, let's say. Okay, so you apply back dy with 1 unit force, either upward or downward. Okay, so now you have drawn, okay, the primary structures, redundant structures, and they are all determinate structures. And you can then solve for this to get the bending equations, because we are going to apply it to take this. Okay, we are going to talk about bending, okay, in beam, frame, arch. Okay. So you can determine your these support reactions, okay, by taking summation moment at A equal to 0. Oops. Yes, then you can solve for MA, summation FY, you can solve for AY, summation FX, you can solve for AX. Okay, so I hope you can try this and solve for support reaction quickly. Okay, later after this class. Okay, but I'm going to explain on but this is maybe you feel like this is in chapter 1, but to complete the explanation for whole things, I'm going to again tell you how to get the bending equation for all this section. I'm going to start with primary structure. Okay, so for this primary structure, we have 4 members. Members AB, member BC, member CD. Okay, so if you still remembered, I said each of the member, at least you need to have 1 cut section. Okay, if there is any loading that will differentiate the shear, okay, or then you need to cut more section. before and after that particular loading. So for example, AB, there is a 48 kilonewton, okay, in the middle. So therefore, you need to cut 2 sections, okay? And then for member BC, you cut only once because it is UDL. Then at DC, you cut only once. So if you can see that, you need to observe M0, M1, and M2, whether this 4 cut section is applicable for all system. Okay, so you need to make sure this cut section and the range and the starting of the X are the same. Okay, and the sign, okay, sign of this cut, the bending moment are the same for all these structures. Okay, then you can start off analyzing it. Okay, so I'm going to start with section CD, let's say. So normally I would just directly solve it here, but I think for the first examples here, I'm going to just show you maybe a bit slowly. I'm going to draw the free body diagram, but still I'm going to directly solve for it. Okay, section DC, and the section is from X. Oops, I cannot remember the. It is 5 meter. Okay, this is 5 meter. So it will be from 0 to 5 meter. Okay, where with my X start from D. Okay, so now I draw my okay, D, and this is not C, this is where the cut section. Okay, so let's say, okay, this is because I'm putting my eyes inside the frame. So when I put in my eyes, okay, this is the positive sign, and when I put my eyes here, this is my positive sign. I'm drawing a positive sign to my cut section. Okay, so this is my X. Okay, so and then if you look at that, there is no loading at all at this section. I'm considering the left section. Okay, so M will be equal to 0. Okay, so then I move to section CB. I'm still considering the left, it's not the left, it's the right section. Okay, so all the right sections, I need to draw it. Okay, so for example, I'm going to draw section CB here. Because I'm cutting it, meaning that I'm cutting the structure into 2 parts. Okay, either the left part or the right part. So this is my right parts. So where I have this 20 kilonewton per meter. Okay, so this is my cut section. This is my C. This is my D. And your X must be always from, a line parallel with your member. Okay, so now I'm talking about CB. So my X starting from here. Okay, so sometimes in our previous assignment, okay, we face some problem in getting the distance. Okay, so you can also in other way, okay, draw your free body diagram in such. Okay, I will put it all. Okay, if you only want to put it this way, there is no problem, but you need to make sure all, because you are cutting again at C, all the axial force, shear force, and bending moment acting at C must be drawn in this free body diagram. So in here, you are going to have CY, CX, and also MC. You need to determine these forces at C. Okay, if you just want to draw member, one member like this. Okay, how to get this? Then you need to cut the section, this CB and also CD. Okay, so here you are going to have CY, okay, CX, okay, and the MC. Okay, so you need to determine this component first and transfer it to the section of interest. Okay, for you to use this alternative. Okay, so there are two. I would say that alternative 1, alternative 2. Okay, so now I'm using alternative 1 here. I will see that I have only one loading 20 kilonewton per meter in my system. So my positive sign moment is in such. So I'm going to convert this 20 kilonewton per meter into my point load. So how much I will get? It will be the area of the UDL, which is 20 multiply the length of this UDL, which is X. Okay, and the distance to the cut section, because it is rectangular, it will be at the center of the distance. So the distance is half of X. So now I'm going to get my moment will be the point load and the distance. Then I check on the sign. If it is acting the same with my my internal moment, the applied moment is same with my internal moments, I have a negative sign. Okay, so this is my moments. Okay, I hope I'm not too fast. I'm going to go to my next section. Okay, so section AB, I use left section. Okay, so this is my free body diagram. Okay, where I start my A, and I already determined my AY, my AX, and my MA. So to get this, okay, this is also drawn positive sign. To get this moment, okay, I need to consider the forces acting at my section, and then my X starting from A. Okay, so I can see that only 48 and 552 will contribute to my moments here. So the first one, I look at the 48 AX, and the distance to the cut section is X. Okay, and if you look at that, this 48, the applied moments will be acting clockwise, while my internal is acting counterclockwise. Therefore, it is positive. Okay, for positive sign. Okay, and then I have 552, which is acting the same direction with my internal, and I get a negative sign. So this is how I obtain my bending moment for this cut section. So I continue with section, but right now this section is from 0 to, oops, I do not know. It's 4 meter and 4 meter. Okay, so this is 4 meter, and this is also 4 meter. So it will be up to 4 meter only. So now I'm going to look at another section also from AB, but it starts with 4 meter. Okay, and end to 8 meter. Okay, so it depends on where you want to start your X. If your X you want to start from here, let's say, then your X range will be from 0 to 4. Okay, so but I do not do this. I do it both start from A. So if I draw my this free body diagram, okay, still I have to consider all the forces acting, okay, in my system. So I have 48 kilonewtons acting at the middle of this section AB, and this is my cut section. Okay, so I have, this is 4 meter, and this, the total is X meter, and this come to here is X minus 4 meter. Okay, so now I have gathered all the information, and I can get my moments here. My moment, you can actually, because they are nothing so special here, you can actually copy this everything to here. Okay, because if you can see that it will be the same. Let us try. Okay, 48x. Okay, I saw for 48. Okay, and this is a positive sign, and then again I saw for 552 minus 552. Can you see that it is actually the same? So without any delay, actually you can just copy everything and move to the next. Okay, so now I only concern on this 48. Okay, so now this 48 also acting the same direction. So I have to minus 48 and the distance is x minus 4. So you can simplify these equations to make your compatibility equation later more easier. Okay, but I'm going to remain in such format. Class, are you okay?
Yes.
Yes.
Okay, I'm going to move to M1 and M2. Okay, but you will see that M1, M2 will be much more easier because it is not dealing with many loading. Okay, it will be due to only one unit force. Okay, so which is, for example, this is R1 is dx. Okay, so you apply this 1 kilonewton here. And of course, you need to determine your support reaction because your cut section for AB is still based on here. Okay, let me draw, put on the, this is 5 meter, this is 6 meter. Okay, so I'm going to start again. Oops, it's happened. CB. Okay, section DC. Okay, class, do you want to try on this? M? Class, do you want to try this?
-1.
It will be 1 multiply
X.
x. So it is x. Okay, it will be positive because it is acting the same direction. Okay, so for your information, I'm not putting both of it at the same side of the equation. I'm directly taking, this 1x to the other side. Okay, therefore it might seem a bit opposite than what you have learned before. Okay, but you just need to know that is, yeah, this I'm just want to a shortcut one steps. Okay, so now I'm going for the CB. Okay, maybe you can help me as well. So now CB, I'm going to draw all my cut sections. My section DC in the cut section, correct? And I have 1 kilonewton, I think here. And my x, remember my x is starting parallel. Okay, sometime in this case, student will might confuse where shall I get my x. I have found in your assignment previously that they consider the x in such, okay, the distance, which is not the right way. So you just start your x, okay, with parallel with the system. Okay, so now this is 5 meter. May I know what is this moment? There is only 1 kilonewton. How to get the moments due to this 1 kilonewton at this cut section? So we have the loading 1 multiply, what is the distance?
5.
5, thank you. This is nothing dealing with x because the distance we measured perpendicular to the point of interest here. Okay, so there will be 5 and it is positive because it acting oppositely. So this is how you get your moment done. Okay, so when you are more, practice more, you might skip drawing this free body diagram and directly put in your table. Okay, so let us try on section AB. Okay, so for section AB, I have this is 4 meter and 4 meter. And you will find that you no need to do for these two cut section because there is no differentiate in terms of loading. So this M and this M must be the same. Okay, so you just need to find ones. Okay, so for example, I have I have AX equal to 1. I have no AY. I have 3. kilonewton meter, and this is my A and cut section, and this is my moment. So class, can you help me to get the moment? So let's start with AX. Okay, AX is 1. Then what is the distance to the cut section?
X.
Yes, thank you. So it will be opposite direction, so there will be a positive sign. Okay, and another one will be 3 kilonewton meter. So this is already in terms of moment, so you no need to multiply with any distance. So it will be 3. So because it's same direction, minus. So this is how you get your moments. Okay, so I'm going to move to M2 right now. Okay, so M2, maybe we will directly put it here. Okay, so now I'm looking at this. Okay, so with my X is start from here, what do you think my M is? Class?
0.
Yes, it is 0 because the loads acting 1 kilonewton will not have any this perpendicular distance to the cut section. So there is no force that you need to consider here actually. So it will be 0. Okay, so how about this cut section I'm talking about, because you can't see my pen here, maybe I put number 2. How about this section BC, for section BC? Okay, my X is starting from C again, same with other. So what do you think my M here?
X.
Yes, thank you. The M will be 1 multiply X will be X. So it is positive. Okay, so how about this for AB? I think, what is this? I think this is nothing here. Okay, so you will see that this AB, the 2 cut section will actually have only one same moments. So can you help me? What is the moment?
6.
6. Very good. So you get it very quickly. Okay, so I hope you can practice more. Okay, in other cases, maybe inclined member will be more tricky. Okay, because you need to resolve forces. Okay, just make sure you know how to resolve using the cos theta or sin theta properly. Okay, but that will be in my example too. I hope you can read it later. Okay. So now once you have determined all these moments, okay, you can quickly sort out with the data, okay, that you would like to put in the compatibility equation. If you are very, your mind's already like a like a very systematic. Without this table, you can also write it directly in your compatibility equations. Okay, but I always do a table for myself. Okay, so DC. Okay, I'm going to write all the members. I have 4 cut sections, so I need to put 4. Okay, 4 cut section. And remember, if you can see that I put it here because there are different EI in this structure. So you need to put this into your comfort. Yes?
Sorry, madam. I forgot to omit.
So, okay, the sections, you need to put in the range properly. Okay. And then after you check that, you put in all the M0, M1, M2 that you have determined earlier. Okay, you may simplify. If you can see that when you simplify, it is more easier. Okay, from this statement just now, okay, if you simplify, just get a very simple for your compatibility equation. Then, this moment, I hope you can already write the compatibility equation when D deal with 1, D deal with 2. Okay, so for example, this D deal with 2, you shall be able to write this. Okay, I'm going to write again so that at least you a revision. Okay, so this is something is missing here. Can I know what is missing here? delta 1, 2, R2. And this will be delta 2, 2, R2. So you have two equations to be solved. Okay, so I'm going to randomly show you how to get this, because we have gone through this earlier. Like for example, delta 1 naught, your equations will be M1 dealing with M1, M naught. Okay, but if you can see that this is dealing with 1 and naught, so you have deal with this 1 and naught only for all the section. Okay, so but I can't see for other of my section. Maybe we look at this range 0 to 5 is 0. Wait, I shall make this smaller. Okay, so let's try. So DC will not give you any result because your M naught is 0. Okay, but CB will give you a result. Okay, let's try on CB. The range is from 0 to 6. You need to put in properly 0 to 6. And then M naught is negative 10x squared. So you put in M naught. This is M naught. This is M1 for the range CB. And you have to put in if there is a different EI, 2 EI. Okay, so this is how you put it. And then you need to plus, okay, all the rest of the section. For example, section AB is from 0 to 4. AB 0 to 4. And then this is M naught, okay, for AB. And then this is M1 from section AB. Okay, so and then EI is EI here. Okay, then you can continue with another section from 4 to 8. Okay, arrange with the EI here. Okay, and then this is M naught, this is M1. Okay, so of course you need to get ready with your calculator or the equations dealing for the integration. Okay, so I hope you can prepare. I mean, if your equations is dealing with sine theta, cos theta, so the integration, what would be this the formula? Okay, if you are going to conduct it manually. Okay, so please be prepared first. Okay, so of course we can determine this delta 1 naught, delta 2 naught. Okay, delta 1 1, delta 1 2, and 2 1 is actually the same. Okay, because you look at M1 and M2, and we have also delta 2 2. Okay, of course I cannot details every of this. Okay, I want you to have a reading later on how to put it from this table, okay, to these equations. So the next thing is to put it in the matrix form or an equation form. Okay, because in this problem it asks in terms of matrix. So here this all the data has been written in the matrix form. Okay, if you need to be also understand, if you want to draw write in the matrix form, it will be just now what I've shown you is in the equation form. So this will be how you write it: the vector delta 1 naught and 2 naught. Okay, the matrix delta 1 1 1 2 to 1 2 2, and vectors R1 and R2 equal to delta 1 and delta 2. Okay, so you put in all these from your compatibility equation just now. Okay, of course this is also complete compatibility equation. I mean the inputs that you have determined for delta, all the deltas. And don't forget about this. What is this? Okay, we need to go back to our redundant or redundant structure, which is dealing with the dy. Okay, because support settlement at D is dealing with dy direction. Okay, so let us have a look on the dy m. Okay, m2 is the dy is subjected to the dy redundant structure. Okay, so you need to refer to this direction. This is upward. Okay, and we go back to, okay, so dy in M2 is upward. Okay, and then settlement at D means downward. So if these are opposite, so we give a minus to this delta 2. Okay, but if this is the same sign, we give a positive sign, okay, for delta 2. Okay, that is why you have a negative here. Okay, so you have to put in the value and you solve for the R1, R2. And don't forget the R1 is dx and R2 means dy for the real support reactions. Okay, then for C, you need to draw the shear force and bending moment diagram. Maybe we can have a quick look on that. Okay, so you have this, so for this two dy and dx, then you need to solve for the remaining support reaction. Okay, so because this seems the two redundants already solved, you can just use this, taking summation MA, you get the MA and so on, okay, of this FY, AY and okay, AX. Okay, once you have solved for all the support reaction, you can use you want to draw the area methods, or you want to use the cut section to get the moment equations. Yeah, it will be up to you. Okay, but in a quick way, you might want can directly draw for the shear force. Okay, for example, okay, you already have this 33.65. Okay, this is acting to your right, so meaning that you are going to the right. Okay, just follow the direction. Okay, because what you have practiced here, okay, this means this direction, and then there is no loads, then you can go straight, and you found a loads of 48 kilonewton to this direction, right direction, so you just go to right direction. Okay, for 48 kilonewton, the depth, then you meet no loadings again, so you can go straight again. Okay, then you close it. Okay, so there is not close here, there is some also forces here. Okay, so you need to determine what is the shear force here. Okay, come to here, this is the internal forces, okay, that you can determine, okay, for the span BC. Okay, so what is this? This is 6 meter. This is 6 meter. Okay, so you need to calculate these internal forces also here. Okay, you need to get this moment first, okay, or shear force first. Okay, then you can solve for the rest of these internal forces. How to get this? Then you need to cut a bit of sections. Okay, cut the sections here. Then you will know that what is the shear force involved here. Okay, not the shear force. If you cut a section here, okay, you get I would like to draw a bit at B. For example, at B, okay, there is something like that. okay, you are going to have this. Okay, this is by. Okay, this would be bx. Okay, this would be by. This would be bx. Okay, we need to know, we don't care about bx here because we just want to know the shear and also the bending moment. Okay, therefore by here is very important. So from these systems, you can see that the one that deal with by is this ay. The rest will not be contributing to this, because you can put in summation fy equal to 0, by is actually equal to ay. Okay, so therefore you can y is equal to also 50.75. Okay, of course you need to determine the moments here so that you can transfer the moments to here. Okay, how to do that? Then there will be more works. For example, you need to include this 33.65 and the 48 kilonewton. I cannot write it. So to get this moment MV, okay, so it will be 33.65 multiplied with the length 8 meter, okay, and then minus 48 times the 4 meter. So you shall be able to get something about the 16.25. Okay, so I believe this is in terms of the other direction. Okay, later you can check it. Okay, so it is in terms of other direction. Okay, so this direction. Okay, maybe I will just directly put it this direction. Okay, this direction. Okay, so you get your shear force and bending the internal forces from your calculation, and you transfer to next member. So for example, you already get this, so 50.75. You can start with drawing it, because at the shear at B is 50.75, and then you know that the loading is in terms of UDL 20 kilonewton, so it must be going in decreasing slope, okay, but straight line. Okay, about how much the depth will be depend on these loadings, so it will be 26. Okay, so 50.75 minus this 120, you will get this 69.25. okay, so of course from here you can start drawing your shear force the other sides. There is no problems. Okay, so you have this 14.35. okay, then you don't have any loads. Supposedly this 14.35 will close it. Okay, if not, you double check. How about the CX? Okay, this is about CX here. Okay, at this C. Okay, so this is how you can draw your shear force. Okay, and the bending moments, the bending moments, can use the area methods, or because I would prefer on the bending equation. Okay, so you can get the bending equation or the shear force equation just now. Okay, to get I mean the specific moments. Okay, at each of the joint. Okay, and then predict predict what is the shape of the connection line. Either it is curved, straight line, okay, or flat line. Okay, so for example, this 33.48. This is based on my positive sign. So if I move to this, if you can see that if I move to this direction, okay, so meaning that I draw at this direction. Okay, and then if these moments just now, for example, I'm going to try on AB for you. So for this example, these moments I get is 33.65 x. okay, minus 93.45. Okay, so once I get these results, how much? Let me check. 4 minus 2.5. So when it is at 4 meter, so I get it is 41.15. Okay, because this I assume it as a positive sign. Okay, so whatever I put it, I get it is a positive value, meaning that I will plot it at a positive sign. Okay, so this is how I determined where is my site of this value. And then I come to here, for example. Okay, so I get it. I can copy everything from just now. And then I minus 48 x minus 4. So my m, for example, my m at 8 meter will be so it will be negative 16.25. Sorry, it's meter. So this, if you can see that negative, meaning that it should be, because what I have assumed here is positive sign. Going to this direction is positive sign. So if it is negative, means that it is going to the other direction. Okay, so which is a negative sign here. So this is how you park this value. Then you refer to your shear force, whether it is supposed to have a straight line or a curved line. Okay, class, I've shared you with this one example, and you need to go back and have a look on my second example. Okay, this is slow, my PDF. Okay, which is dealing with this sloping. Have a look on this example. And let's have a break of 5 minutes and we will continue with the tutorial session. Okay. Okay, I'm going to check, take the attendance also now. Okay, I'm going to dismiss the recording. Shall I dismiss? Maybe not yet. Okay. Okay, done. Akmal, are you here with us?
Yes.
Yeah, can you help me to take your attendance? Akmal?
Wait, madam.
Okay, thank you. And then I'm going to call 5E. Okay, done. Okay, done. Yes. So for the tutorial question, you can go to the I discuss later to download the file. It's here. Okay, class. Do you mind to tell me which question you want to solve? Can you see my screen?
Yes.
Yes. ABC. Okay.
I think.
A. Okay, let's try A. Yeah. I'm going to solve the bending moment together with you. Okay, and then you need to write your compatibility equation. Okay, offline, and then show me, and then I will give feedback. Okay, so at this moment, maybe you can start download your file from the U Future. Okay, we were going to start A. Uh, uh, I'm going to give instruction also in your class, one by one. Okay, just move to. Hmm? Hmm? Okay, so maybe you can draw your primary redundant structure quickly for this case. Okay, I have already put in the WhatsApp room as well. Okay, so of course I'm going to prepare it as well in the screen. Okay, you can check your answer. Okay, so I'm going to draw primary structure. So the redundants have been given to you. It will be only one. Okay, and you take out by. Okay. It's very blur. Maybe I shall put it a smaller one first. Hmm. Hmm. It's a good idea. Very good. Okay, class. Have you download your this file and start? Okay, but just Anis. Anis Nabila? Anis Nabila? Are you here with us? Jasmina?
Yes, madam.
Okay. Have you been able to download from the U Future your tutorial question?
Not yet, madam. I'm still
Okay.
downloading.
Yeah. Can you help to do it? Or if not, you sketch to follow my tutorial now. You sketch from my screen. Okay. So just to try on the new Shohada.
Yes.
Yeah. Do you know what are we going to do now? Yes. Tutorial week 7 in iDiscuss. But if you cannot download it now, you can refer to the WhatsApp. Okay, and draw your primary structure and redundant structure now. Okay. Yes, I cannot wait it for so long. Please be alert. Okay, and all of you right now, please draw your primary and redundant structure. I give you 3 minutes. 3 minutes. Okay, yeah, you need to make it happen. Okay, so and then I will come back to you and I'm going to start on analyzing both structure. Okay. Okay, class, have you drawn your primary and redundant structure?
Yes.
Okay, thank you. So now I'm going to post also the primary structure for you to check. Okay. Oh, thank you, Huda. Thank you. Okay. So please help me to check as well. Okay. Yes. Correct. Okay, and then where is my M? Okay, so I share with the other. Okay, same note. Okay, so now let us start with analyzing both of these systems. Okay, because we have very short times. Okay, now you need to determine the support reaction. Okay, we're going to do it together. Okay, if you can help me as well. Okay, so I'm going to draw. I hope I can draw this skin. So I'm going to draw it using red. Okay. Okay, I'm going to cut a section for this. Okay, cut a section. Start my X here. I'm going to cut a section. Cut a section. Let's say this is 1. I start my X1 here, and this is okay 2, 3. Okay, where I start my X2 and X3 here, and I start my X4 here. Okay, can we do it the same way? So we have the same compatibility equations later. Okay, do it the same way as this one. The sign is also the same. Okay, class. So now you need to determine the support reaction first. Okay, so maybe you can work together with me. Okay, help me. Okay, to do this, we can take a summation. MC equal to 0 maybe. Okay. So now I have AY, I have 30, I have 120 and 60. So I start with AY. AY, what is the distance? Class?
8.
8, thank you. And then the 30 is negative or plus?
Plus. Negative.
Negative,
Negative.
huh? Yes, 30. And then the length is how much?
8.
8. And then
4.
yes, correct. Okay, then how about 60? Negative or plus?
Plus.
Plus 60, okay. And the distance is?
6.
6, thank you. And then we have 120 is plus or minus?
Plus.
Plus, correct. 120 and the distance is?
6.
Is 3, right?
3.
Yes. And then equal to 0.
0.
What else? We have 30, 120, 60, done. So you can solve your AY now. Can you solve it for me? Okay, and you yourself. Okay, maybe I need to go down a bit. Okay, 30 times 8 times 4 minus 30, is it?
Yes. Yes.
Okay,
Yes.
so my direction is correct. So I move to CY now. Summation FY equal to 0. Okay, so now I have CY, AY plus CY is upward. So, and the rest are downward. So I just directly move to the other side. So I have 30 times 8 and 120, right? So now I can get my CY. Correct, CY. So I check back. 30, 120, CY, AY. I form, okay. So 330, am I right?
Yes.
Yes.
Okay, so now I have to find the CX. So my CX, CX is 60 kilonewton. Okay, but to make sure you properly, I just put it like this because CX, my CX is not I don't like this way. I want to change my arrow. Can I change? I cannot. Oh my goodness. I want to draw. My CY, my CX. Okay. So my CX right now is equal to the only loading here. Am I right? Okay. So we have solved for the support reaction. Okay. So how about you? Done? Can we continue?
Done.
Okay.
Done.
So we do for M1 as well, the support reaction. Okay. M1. So now the support reaction is, so we have probably is down. I'm not that sure. Okay. Okay, so let's try. Okay. So taking summation MC equal to 0, and then I have 4 times 1, and then I have AY. Oops, AY is going up, is it? Okay. Minus 4 minus 8 AY. I don't like it. Wait. Okay. So summation MC equal to 0. Okay, so I have 8 AY equal to 4. So AY is half. Okay, so do you get your AY like this? Then summation FY equal to 0. So I have CY must be equal to my AY plus 1. So it will be 1.5 kilonewton. Please help to check the equation. Summation Fx equal to 0. Oops, Cx is 0. Do you get this, class? Okay, yeah? You get this, huh? So let us try to get our moments done. Okay, so I'm going to put in these details. Okay, into shall I do like this? How shall I do it better? This is just too messy. Need a bigger space. I tried. Okay, but this is already messy. CY is not okay. CY is 330. CX is 60. And then AY is 30. Okay, can't. Okay, I'm going to determine the moment for 1-1. Can you help me together? Okay, I'm going to draw the free body diagram here. Okay, so 30 kilonewton per meter with the cut section. Maybe I put a bigger size. Okay, and I have to input all my AY. Why this is so different? My AY is 30 kilonewton and then this is 60 kilonewton. Okay, this is A. So what is my moment here? Okay, for this is 1-1 and my X start from here. Okay, can you help me together? M must be equal to, let's start with 30. It will be 30. X, thank you. So, and then you have another 30 kilonewton per meter. It will be negative. Okay, 30 times the distance is X and the, sorry, this is X minus 2. Okay, so we have 30X minus 15X squared. Okay, so you solve for 1-1. Okay, okay class, are you okay? Yeah. So now I'm going to solve for 2-2 and 3-3. I'm going to solve for in this slide as well. So if you look at this, my 2-2, maybe 2-2, 3-3 to next slide. 2-2 is starting from B. Okay, this is my cut section 2-2. Okay, and this is my X. Okay, so there is no other loadings, no loadings on this section. So my M for this 2-2 is 0. Okay, so now that I'm going to analyze 3-3. Okay, where I start my section from B again, X. Okay, this is a cut section 3-3. And don't forget about you have 120 kilonewton here with this 3 meter. Okay, but not 3 meter, sorry, for this is 1 meter. Okay, so you have this is X minus 1. Okay, so what is the moment? Can you help? 120. It will be 120 X minus 1.
1.
Okay, so I hope you have get these moments. For we have done for 1-1, 2-2, 3-3. Can you follow class?
Yes.
Yes.
Okay, so now we are going for 4. Okay, so 4, we're going to draw the free body diagram here. CY is 330, CX is 60, and we have a cut sections here, and my X is this. Okay, so my moment is dealing with only 60. So it will be negative or positive, class?
Positive.
It is negative because it acts the same direction with the moment. So it will be negative 60x. Okay, so you have done for all your primary structure. Okay, can I prepare for your this redundant structure while you put it tidy? Okay, all your calculation. I'm going to copy the redundant structure now for us to analyze. Okay. So now, where is the redundant structure? CY is 1.5, CX is 0, AX is 0.5. Okay, let's do it. So, cannot group it. Cannot group. Okay. So I still need to put a cut section here. Same. This is 1, 1, 2, 2 with the same sign. Okay, class, are you ready? Can we start with this primary structure?
Yes.
Okay, yeah. So now,
Yes.
okay, primary structure cut section number 1. So I draw the free body diagram. It's only have AY 0.5 here. And my moments, can you help me? For 1, 1 now.
0.5x.
0.5x, thank you. So your moments will be 0.5x for section AB. Okay, so I'm going to move to section B upper. Let's say BD. Okay, so I'm going to start with cut section 2, okay, for BD. Okay, now I draw the free body diagram. This is B, and there is 1 kilonewton acting at B, and you have a cut section. Okay, this is your moments. Okay, and this is your X. Okay, so the moments will be equal to, class?
X.
X. Yes, thank you. So this is how you get your member BD, range from 0 to 1. Okay, so I'm going to go to member BD again, but range from 1 to 4. Okay, where I sketch B 1 kilonewton. Oops, I no need to determine because there is no differential in terms of loading. So therefore, sorry, I'm going to stop this because these moments will be the same. Okay, which is X. Okay, but now there is one more section for us to continue, which is 4, 4. Okay, so I'm going to, let's say this is D again, going to do at CD. So I draw the free body diagram. I have 1.5 at CY, CX I don't have, and I have this cut section moment. And what is this moment? Class?
Negative 1.5x.
0.
Yes, thank you. Because we only can multiply with perpendicular distance. Remember, so 0, done. Okay. So now please put in the table. I'm going to create a table together with you, and then let us put in this information into the table. Can you check, class? Is that all the EI constant for this structure? I'm going to check as well. All elements have the same EI. Yes, okay, for structure A. So I'm going to create a table right now to put in all the information about my M0 and M1. Okay, so I'm going to create it here. Okay, you can create it as well. Oops, I cannot. Oops. Okay, I insert my table. M0, maybe M0, M1 range. And okay, I think this is sufficient. I'm going to put it larger, maybe 20, maybe 18. So I'm going to write my first column with member, and I have 4 card section. Mana dia? There will be AD, I still remember, BD, I still remember, and CD. Sorry, BD I have 2, and I have CD. Okay, with this range, and then this will be X. This is tricky for me. Okay, this is within AD is within 0 to 8. Okay, and then the BD is, I have 2. One is between 0 to 1, and another is from 1 to 4. And CD is 1 to 6, 0 to 6. Okay, I hope you can also do your range now. Okay, and then, oops, I think the formatting will be left later. I'm going to put in the M0 and M1. Okay, this will be, I need to put it this way so that I can get my M0 more easier. From here. Okay. Can I put it bigger? Okay, so my M0 for AD is 30x minus 15x squared. So please check my work. How to subscribe? Superscribe. Okay, then I move to BD. BD is 0. And I move to this will be negative 120 x minus 1. And then I move to the next one. The last one will be negative 60x. Done for M0. Okay, M1. Okay, M1 0.5 x x 0. Okay, so please check this. I've shared it in your chat room. Okay, I think I'm taking quite long time in my briefing just now. Okay, and left you so little time, about 10 minutes to proceed on the compatibility equation. Okay, class. I'm going to stop the recording. Okay. Class, do you follow well the process just now? If not, oh, thank you. If not, then I'm sorry. Then you need to do it slowly lah, until the step we have demonstrated just now. But for those who are able to copy it, please proceed with the compatibility equations. Okay, writing the delta and so on. Okay, I'm not going to do it with you. You are going to do it offline. Okay, so now I'm going to end the class. Not end the class. End this meeting session, and you'll be left for your compatibility equation. I'm going to wait if you are able to produce any. Okay, class. I see you next class.
Thank you, madam. Thank you, madam.
Yeah.
Thank you,
So
madam.
I shall leave you 20 minutes actually, but Yeah, please
Thank
continue
you,
with that.
Madam.
Okay, yeah. I see you next class. Okay, for those who left here, do you have any question for me? Raimi? Raimi? Raimi Moas? Farhan? Nur Farhana?